the other day is just put this in order. So what we were doing, we were trying to estimate, okay, estimating the population mean by the sample mean. So we usually, we start with having a sample, we find the X bar from the sample, and then we are going to guess what is going to be mu, the population mean in general. We cannot give you the exact numbers, so we are going to give you an interval. This is going to be an interval that contains the actual true population mean that we are looking for. So the case that we talk about it was the first case. The case is when the sigma is known. Okay, that's case one. So we create that interval. You see, that's what we have to know. So that is confidence interval when the when the standard sigma, when the population standard deviation is given. If it's given to you, this is going to be just the actual interval. This is going to be percentage of error. The error which comes from this formula. Okay, ZC sigma over radical N. And C is the confidence level, how sure you are that the actual solution is going to be in this interval, 90%, 5%, 6%. And I posted that table for you if you want. If you check, it's called critical values. Okay, table I just posted before the lecture. So just make a copy and just keep it for yourself. This is how we're going to find the ZC, critical value. So if it's going to be 95%, for example, then you get 1.96. If it's going to be 98%, 2.53. The percentage that would be given to you would be follows with this, with these tables. So C is going to be critical values. ZC is going to be critical values. C confidence interval, and then this is it. You just substitute and you get your percentage of error E. As soon as you get the E, then you're going to create this interval for us, and then you are done. So there is one more problem that we are going to consider. Then we go to the case that the sigma is not known. The one in your book is the second case. They briefly talk about this one, but we need both of them. The other problem is if you want to actually do it in practice in future, if you have something that you want to investigate, then your starting point is going to be that sample that I talk about it, the sample size. So your advisors, your research advisor will ask you to do a research, and then he will ask you that just do it and get the percentage of error up to the 5%, 2%. So this would be given to you. Then you have to start. You need a sample size. So there's going to be a converse to this problem. We call it a minimum sample size problem. It's a very easy problem, and you will be given one of them on the test. So you have two choices. You can stay with this formula. In that case, E is given to you, you solve for N, or we are going to give you a new formula in order to get it, okay? So I finish this one first, then I'll go to the case that the sigma is going to be unknown, and this is where we give you the test, okay? So suppose you begin in the order and you want to do it. Okay, this is called, with this expression, you will see it in your problem in the book. Okay, so it's called minimum sample size. Minimum. Okay, minimum sample size. It's going to be minimum sample size for estimation. Or estimation. This means N. Okay, so we just recall that with the formula that we have, you see, recall that. So what we have so far, the E, the marginal error is ZC times it by sigma over radical n. This is the marginal error that we have. So this is, we call it, as we talked about it before, it's called the marginal error of estimation. Marginal error, okay, error for estimating. For estimating mu. Okay, that's the one that we have. Now, if you do a little bit of algebra, I want to solve for n. You see, note that, like an equation. I like the E as E equal to, I multiply the ZC by the sigma to put it on the top. So that's going to be ZC times it by the sigma over radical n. You see, that's going to be the one. You can cross multiply and solve for, okay, or just switch these two, you see. If you consider this one as E over 1, switch these two, it's like a proportion, we can do this one. So if you switch that, give a radical n this time. Radical n is equal to the ZC sigma, okay, ZC sigma over E. And we want to find the n, so square it. If you square both sides, so n would be, n is equal to the ZC sigma over E, everything is square. Make sure you write this one correctly. So this is going to be the minimum sample size formula. Okay, so this is minimum sample size, okay, formula. So this is the minimum number that you need to set up a sample if you want to do the research. And this number, it's going to be number of the people, number of the units. So this must be a whole number. So if it's going to be decimal number, at any level, you are going to round it up to the next whole number. Okay, so this to be rounded. Okay, to be rounded up. Rounded up to the nearest whole number, next nearest whole numbers, next whole number or nearest whole number. So even if it's going to be 5.1, you have to round it into 6. So make sure you run that. On the test, the way they miss it, some people, they don't use the square, use the square, remember. Z sigma over E all is squared. Let's make sure you get it good. Otherwise, it's going to be very easy problem. Any question? So the way they are going to express this E is important to the problem so that we can locate it. They're going to say do the research, to be within, when they say within the 5%, 2%, they're talking about the E. So I give you one so you know how we set up this problem. Okay, are you ready? So that old problem that we talked about, suppose the college president, Palomar, wants to know what is going to be the average age and order a research to the statistic professor or teachers. Okay, so the college, it's going to be one, the college president. College president asks the statistic teacher to estimate. Okay, to estimate the average age. Estimate the average age of the students. at Palmer College, okay, at Palmer Community College, PCC. So the question is going to be, how large sample do you need? See, this expression is used in the problem. They say how large a sample, how large a sample, how large a sample is necessary in order to do it. So when you say how large, you know that they are looking for n. Then they have to give you the marginal error. Okay, so the statistic, the statistics teacher, okay, statistics teacher wants to be wants to be 99%. Okay, 99% confident that that the estimate that the estimate is going to be within, okay, should be estimate should be accurate, should be accurate within 1 year. Within 1 year. You see, within 1 year, this means the marginal error. So you will see this type of expression when this, this type of problems would be given to you. And they are going to give you, of course, the standard deviation. Assume that the sigma is also given to you, and the sigma is equal to 3. The population standard deviation. Okay, so you can't miss it. The problem, the way you are going to express it. So as soon as you see the how large, then you realize that the n is missing. You say this is how we set up the problem. Say, oh, how large? So n is missing. As soon as the n is missing, you have to look for the e, the marginal error. The marginal error, you want to do it so that the result's going to be correct within the 1 year. So the marginal error is equal to 1. Then the only other things that you're going to have is going to be C, the confidence level of the 99%, okay, 99%, and the sigma, which is equal to 3. You will see only 3 numbers in these type of problems. The numbers for the E, the marginal error, C for the confidence level, and the sigma equal to 3. That's it. So you know the formula. Your formula is going to be, that's it. You have to use this formula. N equal to, I repeat it again, is going to be ZC times sigma divided by E all squared. So you have to find the ZC. You have to find the ZC, just come back and substitute. And to get the ZC, you go to that table that I gave you, or I posted. This is going to be the case. Your CC is 99%, and you want to find the ZC. C of 99% over here. And okay, you have 2.58. So 2.58 is going to be ZC. Okay, are you done with this one? So you have to find the ZC in this case. So C is equal to the 99%. You go to the critical value table and you find the ZC, which is going to be 2.58. So you come back and you substitute in your formula. So N is equal to the sigma. ZC is 2.58. You multiply by E, multiply by sigma, which is equal to 3. You divide it by E, which is 1, then you square it. And you can use your calculator, just order of the operation, you do the inside first. inside first, and then you square it. If you do it, your n would be 59.9, but you always round it up. Okay, always. So the number in question is going to be 60. So this means if you want to do the research, at least we need to start with 60 students. You can pick any number higher, but you cannot go any lower. Okay, so if you like, just to understand that, we need, or the teacher need a sample of at least 60 students. 60 students to be able to do the job. Any question? So easy problem. Just don't make. You need the CC to get these numbers. So just make sure don't use the correct formula. Use the correct formula. Otherwise, it's going to be straightforward. And you have a couple of them in your assignment, and we just give you one of them on the quiz. You have, I think, one to practice on the practice test. Okay, so we are done with the type 1 of the estimations. Any question? So what we did so far, we did the estimation for the population mean, mu, by estimating it by the sample mean. But the crucial part was sigma was given to you. Okay, sigma is known. When the sigma is known, since you find the ZC, this is called z-test or z. Okay, that's it, z-test, the z interval. And I'll show you how you're going to do it by your calculator the other day. And so the question is going to be, what would happen if the sigma is not known? Because your formula, you see your main formula, the CC, the base of our argument was, was the fact that the sigma was given to us. So what we're going to do, so we're going to get the case 2. We are still in that section. This is how your book starts talking about this type of idea. So what I did so far is not explicitly, if you like, in your book. It is in your book, but you don't have this type of definition and construction. Now we go back to what you have in your case. Yes, so we are going to do the estimation when the so confidence interval when the sigma is not known. So that's going to be case 2. We're going to have 4 cases. Okay, that's going to be a confidence interval. Confidence interval for the population, population mean. Okay, population mean mu. In this case, when sigma is unknown, sigma is not given to you, or sample size is small. Both cases can be used. Sample size is small means n is less than 30. So if sometimes you have thought about it, which case are you going to use, the first or the second case, you can focus on the sample size. If the sample size is going to be greater than 30, everything would be z-test. But if the sigma is not given to you and the n is less than 30, so in that case, you cannot use the z-test. You have to use the one that I'm going to talk about it. Now, let's see what's going to be the difference and what we need. Okay, any question? Everybody understand the problem? In this case, the case is that the sigma is not given to you. Sigma is unknown, so you cannot use the z-test. So just recall that, just remind you that, recall that if a sigma is known, remember if sigma is known, then we can use the z-score, okay? Z is equal to the x bar minus mu over sigma over radical n. Okay, that's going to be the case. And the confidence level and the confidence okay, confidence interval for mu, for population, for mu. Okay, is going to be what? This is the one that we talked about. It's going to be x bar minus e less than mu less than x bar plus e, where e is going to be equal to the zc sigma over radical. We are going to copy this one. That's why I rewrite it. Okay. So what we say that in this case, one uses or can use if you like. I just wanted to see this expression. One can use the z-test if you like, or the z-interval. The z-test or z-interval. If you want to use calculator, it's a z-interval. Okay. Now, what's the question? The question is going to be, if sigma is not given to you, you see, if you don't have the sigma, you cannot write this formula for the z. Okay, you cannot find this formula for the z. If you cannot find the z, then you cannot go on to get these numbers. So what we're going to do, we are going to change this variable z. So far, we're working with the z. So what we do, we are going to introduce a new variable. So we're going to create something new. That something new is going to be x bar minus mu over s over radical n. Because you do have the sample size, you see. The sample size, the standard deviation would be given to you, or the sample is so small that you can find it yourself. Okay, so the question is going to be if the population standard deviation, if the population standard deviation, okay, sigma is unknown, and n is small, less than 30, okay, is small if you like, is a small number. So we cannot use the so-called z-test, the z-test or z-interval. Okay, so what we are going to do, we are going to introduce. Okay, so in this case, we are going to introduce a new variable. So we introduce a new variable defined by, so this variable would be denoted by t. It's going to be t equal to the x bar. Okay, t is equal to x bar minus mu divided by s. Remember, lowercase s is the sample standard deviation divided by s over radical n. S over radical n. If you compare them together, the only difference is just, you see this one, the top is the same, x bar minus mu and the x bar minus mu. The bottom one, we have the sigma here, but over here we have the s. Okay, and from now on, this is what you do in statistics. You're going to have two cases, t-test and z-test. Now, if you change the values, of course, this t would be changed. So it's going to be a new variable. And this is going to be called Okay, they call it a student's t distribution, which is t distribution. So the distribution, this new one, the distribution is not going to be z. You are not going to have a z curve. Everything would be new. So the distribution of the variable t is going to be called, okay, it's called a student. That's it. It's called a student's t distribution. T distribution, or just, or t distribution. T distribution. And the reason that we call it a student t distribution is that the guy who just invented this one was working for a beer company, like I think it's a Budweiser or something. So he was working for the company, he invented this one for the company. So he couldn't publish the results because that was part of the company, research. So he published his result, but under the name of the student distributions, okay? And if you want to know his name, and that's it. The guy name is William. Okay, it's William, I think Gossett. This is the way you pronounce it. And he did it years ago, 1908. Maybe that's his birthday. So this is going to be a new thing. So again, you have a new distributions. We did have a Z curve. So in this case, we have a T curve. You see, if you graph this one, it's going to be like the Z curve. Okay, this is going to be the T. The difficulty for to graph it is that because of this N over here, okay, this graph depends on the sample size. So if you have different sample size, you see if you have a deeper sample size, then you are going to have different Z curve. So it's just going to be different one. Okay, different one. So if you want to work with the T values, then you have to find out which of these are you talking about. So in order to make sure that we are going to identify the specific one, there is going to be a number related to these. We are going to call that number df. You see, this is, I'm going to introduce it. We call it degrees of freedom. Degrees of freedom is going to be n-1. So if you want to refer to a specific one, then you have to find the degree of freedom first. For example, if this is going to be the first curve, it's the degree of freedom over here is going to be 1. Then this is going to be the one when degree of freedom is 2, degree of freedom is 3, etc. So if you change you've changed the sample size, you are going to have different graphs. I'm going to write down this one for you, but everything else is nice. The area under the curve is 100%. It's symmetric, so we can use it for probability again. And if the sample size getting bigger and bigger, this is going to be eventually like a Z curve when the sample size is going to be bigger than 30. So that's why we're just using it for the small samples. Okay, let me just give you explanation for this one. The difference between this one and the one that you have. So you are going to note that they are going to be different. So the difference is going to be, there is going to be a different T distribution for different sample size. Different T distribution. In case of the Z, you have only a single one. Different T distribution for each sample size. For each sample size. Okay, so you have to graph it anytime you want to talk about it. So what we're going to do, we identify the specific one by a degrees of freedom. So we identify we identify a particular t distribution. Okay, particular t distribution. A t distribution by degree of freedom, by giving its degrees of freedom. That's the expression. Okay, degrees of freedom. Freedom, or in short, df. There, that's the formula for the df. df is equal to the n minus 1. Okay, so you've got to be careful in this course. Anytime you see the df, maybe degrees of freedom, and the df would be n minus 1. The other property are going to be just like the z-curve. So also, if you like, the area under the curve is 100%. So nicely, we can use it for probability again. So the total area, under the t-curve, the t-curve we call it, or t distribution, is 1 or 100%. So it's going to be used for the probability, same thing that we did before, and is also symmetric about the 0. So the t-curve is going to be symmetric. Okay, it's going to be symmetric about the origin, about the origin. So that's going to be 1. It's like the z-curves. And we talk about degree of freedom is equal to the n minus 1. And if the sample size is going to be large, then this would be getting closer and closer to the z-curve to get those numbers. Okay. And now, since we set up the curve part, everything else is going to be like the one that I did with the z distributions. So if you continue with to find the marginal error, remember the marginal error in case of the z-test was zc, sigma over radical n. Now you have to create something new, then something new would be tc rather than the zc, and then the formula would be almost the same. So now we can give you the formula. Eventually we copy that one because I did it once. I told you the one that I did can be repeated over and over. So we did once, and then we are going to use it here, and then we're done. So that's official. What is confidence interval? It's what you have to memorize to use it. What is confidence interval? Okay, confidence interval for the population. Okay, for the population mean. Population mean when the sigma is going to be unknown. As I talk about it, sigma unknown, and or n is small. Okay, so it's going to be given by the formula is the same as we did. Mu is going to be, again, it's going to be between x bar plus e, and the x bar minus e, but e would be different. So it's going to be where e this time, e is going to be tc. Okay, it's going to be tc times s over radical n. So you replace the sigma. Sigma was standard deviation, population standard deviation, we change it to the sample because you have a sample which is a small. This TC is going to be critical value in this case. Okay, so where TC is the critical value, is the critical value that you are going to find it, if you like, by the table that I posted for you, that can be, okay, can be determined. Of course, we can do it with the calculator. I'm going to show you. Determined using, okay, using T table. That is going to be the case. Now, the T table is the one that I just posted for you. It's very, very nice table, and we're going to use it quite a lot when we get to the final part of the course. Of course, the calculator is fine, but there are some other things that we do in future. Sometimes it would be easier with the table. So let's see how we're going to read that table. Let's see, like, bring a copy that I posted for you. I can find one. Okay, this is the one that I posted for you. Okay, it's the one we call it T table. Okay, the T distribution. Okay, so in this table, this is going to be the T curve. You see that's a T curve. In this one, when you start, there are two rows. The first one and the second one, forget it for the time being. You come back to it for the final exam. That's a one tail area, and the two tail area is the one that we're going to use at the end of the course. But you are going to use the third row here. You see the third row start with the C. C is the confidence level that you have. You see 0.5, 50%, 75%, 80%, 85%, up to the last one that you have a 90% and 99.9%. So this first row would be the C. Then this column would cover the DF, degree of freedoms. Okay, degree of freedom is n minus 1. So in order to find these numbers are going to be TC. You see the numbers are going to here. These are going to be the TC. So the way you are going to use it, you have the confidence level. For example, if you have a confidence level of 80% and the sample size of, let's say, 16. If the sample size is going to be 16, so you find the DF first. DF is 15. DF is going to be 15. Then you move on. You see this is it. This is the DF of the 15. DF of the 15, for example, if if the confidence level is going to be 95%, so the numbers that you read for the TC is going to be 2.131. Very easy to work with this table. Okay, so this is how we're going to find it. So make a copy for yourself. It's very useful. The first two rows are going to be used for the final, but for the time being, just this one. Okay, so the line 3 here, the top, that give you C, the confidence level. The DF, this column is going to be the degree of freedom, and the degree of freedom would be n minus 1. So to remember it, you can write it down on your test, if you like, or your table, that the DF is n minus 1. Okay, so I just give a couple of them to know how we're going to pick these. Okay, so and then we do the actual one. Actual one can be done by calculator too, but this is not bad. It's a very easy way to do it. Okay, so let's get one example to write it down for you how we're going to find those TC. So, for example, we wanted to find the TC for us. Okay, so so let's find TC value. Find the TC value for a 95% confidence. Okay, confidence interval. confidence interval with the sample size, with the sample size of 22. You say this is going to be your problem. For example, you want to find it. So this is how we're going to do it. So solution. So the information that you have is that n is equal to 22. So you have to find the degree of freedom. So this is it. Degrees of freedom would be df is equal to the n minus 1, which is going to be 22 minus 1, which is 21. So the df of 21. So your df is 21. You see df is 21. And your C is 95% or 0.95. So you go to the table, you see you go to the table and the first column, you are going to identify where is 21. So that would be 21. And then you keep going, you see, you go to the right and you match this number with the 0.95. Okay, 21.95. So this is going to be what we are going to end up. 21. So that is 21. Okay, that's a 21. Then you want the 95. 95 on the top. This is 95%. So 95, 21, 95, 20. That's it. 95, 25, 21. So that gives you 2.08. Okay, that's 21 for the degrees of freedom, and you match it with your C number, which is going to be the number from the third row. So the number is going to be 2.008. Okay, any question? It's very easy to find. So this number is going to be 2.008. So you can name that your TC is going to be 2.008. Okay, so this is how we're going to do it with this calculator, if you like, to get these numbers. Okay, so this is going to be your job from now on. Any confidence interval problem, if the sigma is known, you are going to use the ZC. If the sigma is unknown and the sample size is less than 30, because if the sample size is going to be bigger than 30, whatever standard deviation is given to you, you can consider to be sigma. But if the sample size is less than 30, as I told you, you'll be confused in your book. You know, they give you various cases, but this is going to be the way we're going to do it. If the sample size is going to be less than 30, let's just give you a remark before we give you an example to see how we're going to. From now on, whatever we do in this course, we have to do it in two different cases, the T case and the Z case, and we focus on the sample size only. Okay, so give you a remark to conclude this one. This is going to be how we're going to handle it. You know, if you read the different statistic books, this part, some of them are a little bit different, but we want to set up a norm so that we are going to follow this. Okay, so the first part is if sigma is known, if sigma is known, use ZC. Okay, ZC for the confidence interval, for the confidence. Okay, confidence interval. Okay, and so your E would be ZC sigma over radical n, and then you write the confidence interval. Okay, so that's going to be the case. Now, if second case, if a sigma is unknown, it's not given to you, is unknown, then you check the sample size, and n is less than 30. The cut is 30. Remember, the reason is that central limit theorem that we talked about it before. When the sample size was bigger than 30, if you remember, everything would be X bar would be normally distributed. So the sigma is there. So when it is less than 30 is where the sigma can be unknown. So that's why. If this is going to be the case, then you are going to use TC. Okay, use TC for confidence interval for the confidence interval, and your marginal error is going to be TC. TC but S over radical. Okay, don't miss it. So that gives you the second case. Okay, I'll give you a break. We come back. We give examples. How we're going to do it and how we're going to compare it. There are two different types of examples. The first one is straightforward. The second one is again for the rest of the course. This sample size is small. And they give you the sample. They give you the numbers. Okay, they give you the numbers. Then you have to find, you find the standard deviation yourself. So you have to refresh your memory and make sure you are ready to get the standard deviation again. Okay, so 10 minutes. So then we come back and we do it. So this is going to be estimation, the confidence interval for the population mean. And we give you the test up to this one. And then we have later on, we have a similar one for the proportion or the binomial the distribution. And then we have one for the standard deviations. Okay, we do that. The standard deviation, we need a new curve. We do those, before your quiz, quiz 4, and then that will take us to the final. And then there is one more argument that when you get these numbers, you are going to be challenged. We have one more concept. We call it test hypothesis, and then we're done. Okay, it's almost 11:10. 10 minutes. We come back and give you the example to see how far we can go. Oops. Okay, so let's give you an example. I'm going to do it. Any question? So make sure to identify the test that you're going to use. Sigma is given to you, z-test. Sigma unknown, sample size is small. We're going to use the z-test, okay? A t-test. So there are two types of problems. The first one is a little bit short, but the second one takes times. So the first one is going to be this one. Situation will be created, okay, with a small sample size. So this is about, sometimes, and the police stop you maybe to check your tires, the depth of your tread depth of the tire. This is these type of problems, okay? So this is it, 10, okay, 10 randomly selected cars. Okay, selected cars were stopped. And that is going to be one, and the tread, okay, that's a tread depth. Tread, that's correct. Tread depth of the right front tire, of the right, okay, of the right front tire. Front tire was measured. Okay, was measured. Like, when you want to release your your car, okay, return your car from the lease, something, you have to check it. So the report is that the mean was 0.3, okay, inch, and a standard deviation, a standard deviation was 0.08 in inches. Okay, so as you can see, this is all about the sample. The sample size is 10, which is a small, less than 30. And the sample mean is 0.32, and the sample standard deviation is 0.08. Nothing about the population standard deviation. So what's the question? The question is going to be find the 95% confidence. Okay, confidence interval of the mean depth. The population of all the tires, mean depth. Okay, that's going to be the one. So you read the problem carefully, you identify that this problem is related to the confidence interval, because they are going to tell you what's the confidence interval. So this problem of a confidence interval, so what we're going to do, we're going to check to see what we have. So the solution is going to be, so the confidence interval about the population mean. Okay, just what's that? Okay. Just checking why I get these. Okay, that's all right. Okay, so what is the sample information? Okay, sample data. Sample data is all about the sample. So we start with the sample mean of the 10. Sample size of the 10, the sample mean, X bar. The sample mean is 0.32. And in this case, we have a sample standard deviation. So we have the S. Okay, we have the S, nothing about the population. That's it. So the confidence level of the 95%, 95%. So you have to find the marginal error. That's how you set up the problem. Now you have to pick the test. Is it the t-test or the z-test? You see, a standard deviation is given to you, that's it. Or the sigma is unknown and the sample size is less than 30. So this means you have to use the t-test. Okay, it's just for your information. You check, you say that, note that sigma, it's just for your information, sigma is unknown. Sigma is unknown and the sample size is very small. Okay, then you realize that the t-test must be applied. Okay, t-test or t-interval must be applied. Must be applied. Okay, so you realize that your percentage of error, your error can be found from this formula. Okay, you have the TCS over radical. So that's important to realize that this is going to be case 2, if you like. Any question? So make sure don't pick the wrong test. Then you have to find the TC. We can use it that table that we talk about it. Okay, so we have find the TC, n is equal to 10, n is equal to 10, so degree 10, degree of freedom would be 9, degrees of freedom is 9. If you like, you go to the table, you identify the 9, and you go up here on the first row, you identify the C of 0.95, then you read this number. You see, if you do it with the table that I posted for you. Okay, so that was the table, the table. Okay, so I have the number. I just want to show you that I missed that. Yeah, that's might be. Okay, this is going to be. This is the table. Okay, so degree of freedom of 9. So this is going to be the 9 that we have. That's 9. You see, that's 9, and you go on and you compare it with the 95%. If you go with the 95%, the number is 2.262. Okay, this is the number. Okay, degree of freedom of the 9 and the 95% over here. 2.262 is going to be the one. Okay, so the TC is going to be, TC is 2.262. That would be the TC. Okay, make sure don't miss this one. Okay, any question? Get these numbers. Yes, Clayton, you're right. And I got your email. I check your quiz again. I know that. Okay, so that's going to be the case. 2.262. Any question? So go back, substitute here to get the E. Then you write your interval. Okay. So go to this side and we work on the E. So the E is, I just repeat it, it's going to be TCS over radical N. So we substitute, we have 2.262 times S. S is 0.08 divided by radical N. N is 10. Okay, if you use your calculator, you should arrive at 0.057. Okay, in inches. So this is going to be the percentage of error. Okay, now we are ready to give you the interval. So the interval is going to be, okay, this is going to be the interval. Remember, the interval is mu between x bar plus e and the x bar minus e. So the x bar was 0.36. Okay, that's just 0.32. 0.32 minus 0.057 less than mu less than x bar, again 0.32 plus 0.057. Okay, you can check it with your calculator, but this is what I have. I have here 0.38, okay, 0.38 and 0.26. Okay, both of them in inches. So this is going to be the range that you think that the population population mean is going to be for all the tires. You see, for all the tires, the mean depth is going to be between 0.26 and the 0.38 inches. But as we did it before, you have to make a comment. Okay, based on this information, you get the result. So different way to do it. It was 95%. There is a chance, 95% chance. You know, it depends what you want to write or how do you want to write it down. It's like one can be this one way. One can be 95% confident, or there is a chance that the population, okay, the population depth mean or just mean is going to be between 0.26 and okay, 0.38 inches. So that give you the final answer. Okay, any question? So the important part is the type of the test that we're going to use and the way we're going to set it up. Now, if you want to use your calculator, you are welcome to use it, we don't mind, but you have to give us the preliminaries, that what type of tests are going to use and what's going to be your formula for the confidence interval. Then you can use the calculator to give us the final answer. Remember, we talked about the z-test the other day. So I think you have to go and find the test. So that's the second. That is that's a distribution. You're not going to get it here. We go to the statistic. That is going to be a statistic. Okay, so this is it. I do it again. So I go with the, let's go back. You see, that's going to be the one. So I turn it on. Second statistic. And there is a number from the past that I have to clear it. Then I do it again. Okay, I click on this one twice to get it. You see, that's what you are going to get here. So you have to go to the tests. So we go to the test, and we did it the other day, remember? The other day we did the number 7. We did the number 7 for the z interval. You see, that was number 7 for the z interval. So you have to go down to get to the t interval. Okay, so for this is going to be t interval. So you click on the t interval, then you see this data that you need to put in. So the data start with the, see, the need for the sample mean. So we go to the sample mean. The sample mean was 10. So we change this one into 10. That's a sample mean. Then you need a sample standard deviation, 0.08. So we go this one and we get the 0.08. Then we go to the sample size. Sample size is 10. So that would be 10. The confidence level, is of, we have the 95. So the 95 is already there. Okay, that's one. So we go down and we ask to calculate it. You see, that is going to be the the intervals that we give us. What was the number? Should be, did I make any mistake? Over here. So as I do it again, but I missed. So that's the second and the test. For the test, we go to the number 8. So that was a test. So for the statistic, oh, the mean was, sorry, the mean was 0.32. So that's a 0.32. Then standard deviation 0.08, 10. Yeah, I missed the mean. So I go on and I ask for the calculation. That's it. You see, I got the interval of 0.26, 0.377, which is 0.38 right away. That's the one that we got over here. Okay, 0.26 and 0.38. Okay, so it's nice for the T. We can use it. We don't mind. But you cannot just, you know, I was talking about this one before. You cannot just give us this final answer as an interval. You have to set up the problem. While using, you know, what type of test to use, okay, what type of test to use, and what's going to be your interval of confidence interval, then apply the calculator. But if you do it, then you check it with the calculator, that would be better. But you know, you have the option, but not just give us a number, you don't get it. You get only points for the final answer. Okay, any question? That's a type 1. The type 1 is straightforward, everything was given to you. There is another type most of the time, the second type. But we give you one from each on there, okay, on the test. And this problem is going to be with you for the rest of the course. There are some other concepts, one more other concept, then you may have to do this one again. Now, what's going to be this case 2? The case 2 is the actual data values would be given to you. Okay, so you have to set up the mean and standard deviation yourself. So that it takes a little bit more time. You have to manage your time on the test. So what we are going to do, we are going to go around and check the number of the calories in a French fries, okay, portion of French fries in different fast food restaurant. That's the problem is going to be about. Okay, so there you are. So the problem is that we have some numbers, the following. Okay, the following data are from, we have the data from 8 fast food restaurants, 8 popular fast food. Okay, fast food restaurant regarding number of calories, number of calories in 3 ounces, 3 ounces of French fries. French fries. Okay, so 8 of those restaurants, and this is what we got. So we check, and these are going to be calories count, if you like, for each of those restaurants. 222, 255, okay, 255, 254, 254, 230, 230, 249, 249, 222, 222, 237, 237, and 287. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 restaurants. Okay, so these are going to be the number of the calories. So what we'd like you to do is, would like use this information, use data to find a 99% confidence interval. Okay, confidence interval for the mean calorie, or the for the mean calorie count. Okay, in 30 ounces, or the 3 ounces of French fries. French fries. You see, this is going to be your problem for this one. Of course, as you can see in this problem, the sample size is small. We have 8, and it is going to be less than 30. So eventually you have to use the t-test. But the first thing to do is you need more information about the sample. You have to find the mean and the standard deviation of a sample first. Then you can set up your problem, okay? So officially, this is going to be what we have, solution. Yes, we know there's confidence interval about the mean. So we have to use sample information. So the sample data that we need. Okay, the sample data that we need is the sample size. The sample size is already given to you, is equal to the 8. But you need the sample mean. So the X bar is missing. You need sample mean is missing, and you need the sample standard deviation. Sample standard deviation is also missing. Okay, so there is not going to be population standard deviation. The confidence level is 99%, and so E is missing. Okay, that's going to be one. So your first job is use your calculator to find those numbers. You know that if you want to calculate, you can do it, but it takes time. So, but if you want to do it, remind you that. You see, that was X and the X squared. You have to set up this one. So you have to list the numbers here and add them together. Just remind you if you want to do it right here. But your X bar would be sigma X divided by N. So this would be 244.5. Let me check it with calculator as well. And if you want to find the standard deviation, then you have to use this formula. Standard deviation of, remember that was a sigma X squared minus a sigma X, then a squared, then divided by N, the total 1 divided by N minus 1. That is the formula, and the result would be 21.7073. So if you want to do it without calculator, just make sure to get practice. You know how to do it. But the calculator one, you know that we just add them together, and we did have. You just put it on the data and just give you those numbers right away. Okay. So different format to get this one. Go to the second and the variable, and that was the. You have to put the numbers in, to get it, to get those numbers. I can try it later for you to see it. Okay. So so this is going to be the first part. You have to. This is your job for not only this problem. Later on, we get to the fact of the standard deviation. You have to do the same thing for that one too. Okay, so just get practice. Make sure to get these two numbers. Any question? Now we can set up the problem. Set up the problem as the following. And you had quite a lot in your book. They like this type of problems to have all the information ready. Okay, so this is a new situation that we have. We have the sample size of the 8, and we have the sample mean of the 244.5. Then we have the standard deviation of 21.73 and the C of 99%. Okay, now it's always the t-test for this one. Just remind you that, note that n is equal to the 8 and 8 is very much less than 30. Okay, and so t-test must be applied. Okay, t-test must be applied, and so in this case, E is equal to the TC S over radical N. So we have to find the TC from the table. Okay, N is equal to the 8. So N is equal to the 8. So that gives you the DF of 7. DF of 7. So we go to your table, and this was the DF, and you find the DF of the 7, and you're going to match it on the top with the 0.99. To read that, the TC from the table, you say this is it, 7. So this is 7. This is the DF of the, okay, DF of the 7, and the TC of the 9. Be careful, you have two cases over here, 99.9 and the 99. Make sure to pick the correct one. Okay, it's going to be the 99. So in the case of the 99, the number is this one, 3.499. Okay, 3.499 is going to be your TC. So the TC is going to be 3.499. If you want to use this method. So that's it. So the E is going to be equal to the 3.499 times it by S of 21.73 over the radical N, which is a radical 8. And use your calculator to get this percentage of error. So if you do it, you can double check it, but the one that I have, the result is 26. Okay, I have 26.88. So that gives you the percentage of error for this one. Okay, let's see any question. So we are on chapter 7. Somebody asked me chapter again. Chapter 7. This is 7.2. Okay, so this is going to be the E. Now give us the interval. So the interval is going to be x bar minus E, x bar minus E less than mu between x bar plus E, x bar minus E. So we substitute. So the x bar is 244.5 minus 26.88, and it's going to be less than mu. And this is going to be 244.5 plus 26.88. And if you simplify it, so that gives you 217.6, and you have 271.4. This is the number of the calorie counts. Okay, so you may run that, this one into the 218 and the other one to the 271. You have to make a comment. We were at the 99%. So there is it. You have to make a comment. There is 99% chance, if you like. 99% chance that the population, okay, the population mean is going to be between, okay, it's going to be between 218, Okay, between 218 and 271. 71 units of the calories. Okay, so based on this information, you can make this nice claim about the about the job, about the things that we have over there. Okay, any question? So we can let me just check it with the calculator so that you can see that. If you want to do it, you are welcome to do this. But we have to find the X bar and the standard deviation first. Okay, so let's check. See if we got it right. Clear this one. We go to the statistic. So the tests. That's a test. You need a T interval, number 8. T interval. You see it here. That's a Z. Go once more to get a T. So that's where we want. So we are going to bring the information that we have. You have the mean. Your mean was 244, 244.5. That's a mean. Then a standard deviation of 21, 21.73, 21.73. Then the sample size 8. So we go to the sample size. This would be 8. The confidence level is 99. So we have to change this one into the 99. So we go and calculate. That's it. 217.61. Okay, which is the one that we call it 218. And 271.39 is the one that we call it 271. Okay, 218, that's it. 218 and okay, 271. So it's very good, very easy to find with the calculator. You set up it nicely and you get this number. Okay, so be aware of this case. This case takes time because you have to find those numbers yourself to get the result. Okay, so that's going to be the confidence interval for the mean. We are done with the mean for both cases. Okay, known and the unknown. Then we keep going to get the others. Your book start with the proportion, which is much easier for the proportion. I have a little bit more time, so I just give you an idea of the proportion, but we are not going to give you any question on this one, on this test. You see now that you know everything about these two cases that I set up, or I can do one of the preview because I won't get time to do this one before the test, and I want you to concentrate on this test. Okay, so we give it a test up to this section. This is 7.2. 7.1 is proportion. Intentionally, we didn't do the proportion first, so we go with this one first. This way we're going to give it a test. Okay, so what's going to be your test covering? Your test would cover, of course, unlike your quiz, you should be able to read the Z-score tables from the calculator or otherwise, like the first question that you did have. Then you should be taking care of the normal distribution. Okay, normal distribution, direct problem and indirect problem. Indirect problem, those warranty things that we talk about it. Then you should be able to do the, let me write it down for you. This is what it's going to be about on the test, and each of these will be repeated on the final. So that is going to be the topics on test 3. Okay, the test 3, the first one, reading a Z-score. Okay, Z-curve. Z-curve reading, if you like, that's going to be one. And the second part is going to be normal distribution. Normal distribution. The third one is going to be those application problem. We call it inverse normal. Okay, if you like inverse normal. And that was the application problem that we talked about it. We give you one of them, we give you two on the test, on the quiz. Okay, that's a 1, 2, 3, number 4. Number 4 is going to be distribution of a sample mean, P of X bar. P of X bar, distribution. Most of you did this one right on the quiz. I post the solution for the quiz too. Distribution of sample means. Oh, some of you didn't correct for continuity for this one. That was what you missed. Okay, 1, 2, 3, 4. Then normal approximation. It's the one that it was briefly in your book, but we talk about it. Normal approximation. Approximation to the binomial. Okay, that's number 5. Okay. So number 6. Number 6, confidence interval. Confidence interval when the sigma is known. Okay, that's a z-test, we call it. And the one that I did today, number 7 and 8, we give you 2 problems on this one. 7 and 8 would be confidence interval. Okay, confidence interval when sigma is unknown. When the sigma is unknown, of course, you know that you have to use the t-test. T-test, there was one over here that we missed, and of course, one problem on the minimum sample size. Minimum sample size for estimation. Very easy problem, but some people miss this one. The formula. You cannot do this one with your calculator. Remember, you need to bring it. ZC sigma over E all squared. That's it. We put them together, it's like a 10 problems, and then you are going to answer 9, or we may give you 11. And all of them would be repeated on the final. Okay, we may drop this one for the final and number 1 at that time. But the rest, you are going to see it on the final. Okay, that's how important is going to be the topics on this test. And we have, something like 4 or 5 questions we covered on quiz 4, and then whatever is in quiz 4, put it given to you on the final. Okay, so it's just a study. This one is a double bonus, and you get it right away. Okay, any question? Let's go to the review and try to do one of them. Is going to be too many, maybe not get time to finish it on. Okay, on Thursday. So you have to study your quiz. Remember, on this review, I have one question from the quiz, but you have to study that one. I didn't put anything for the quiz. I may post a take-home one for you over here. We give you 4 points, so that would be useful for you. Okay, the take-home quiz, we call it. So it's going to be due on the day of the test. We give one here, and we let you collect some extra point and give you some idea really to make sure you are ready for the test. Okay, so what I'm going to do is I'm going to do that number from we have one problem on the normal approximation. We didn't do much on this one, so I explain this problem for you, and then I post that take-home one for you so that you get more on these numbers. Okay, any question? This is what I'm going to do. Just show you. This is the one that you have. Okay, can you see it? You see, I'm going to do number 2 here for you. Number two records show that 3.5% of the general population will live past 90th birthday. If in a graduation of 753 high school students, use the normal approximation to estimate what is the probability that 15 or more leave behind the 90 between 25 and 35. Okay, that would be the normal distribution one. Even if you want to use your calculator, you have to do it. You do a couple of parts of this problem. You can only use the calculator at the end. Okay, this problem takes time because you have to check the various conditions that we have, but it's not bad. Okay, so go back to my notebook and I tell you how we are going to collect the information. So you read it carefully, you find out it's a normal approximation problem. So you can't miss it because we are going to give you, use the normal. You cannot use any other method. Okay, so that would be practice. And we finish this one. There's practice test number 3. And the problem that we're going to talk about a little bit is number 2. And this is a normal approximation. Normal approximation, okay, of the binomial, to the binomial, to the binomial. Okay, we collect the information that we have. The situation is that this is it, the probability of success, if you like, 3.5% people will leave after 90, so the P is going to be 3.5%. Okay, which is going to be 0.035. This is given to you. Okay, so we pick a sample of 753 graduate, and then we want to answer these questions. The first part, we try to do it 15 or more. So what's the probability that R is going to be greater than equal to the 15? What's the chance that 15 of those people would be alive after, okay, their 90th birthday? So what you have to do is you have to confirm, you have to check that the normal distribution, normal approximation is possible. There were 2 conditions that you have to check. You see, your P is equal to the 3.5%. So you have to find the Q. Okay, and you find the Q, and the Q would be what? Would be 96.5%, which is going to be 0.965. Okay, that's 3.5%. So that would be the case, okay? And the N is equal to the 753. First, you have to check the condition, okay? If you don't check the conditions, you're not, you have to confirm that we can do it. So the condition is N times P must be bigger than 5. N equal to the 753, okay, 53 times the P, which is going to be 0.035. Okay, so just use calculator to get these numbers. Okay, I don't have the numbers, so I just do it. So this is going to be 753 times it by 0.035. Okay, so it'll give you 2355, 26. You can call it, you can call it 5 or just 6. It's fine. So this is going to be the number. It's bigger than 5. So the first condition is satisfied. Then you check the second condition, N times Q. N is 753 times the Q. Q is 0.965. And you have to find it. We know that it's bigger than 5, but you have to show that. Okay, so that's it. 753 times it by 0.965, 965. And the result is quite about 726.6, 7, okay, 26.64. It's bigger than 5. Okay, so now you can see that the condition is satisfied. So you claim that the normal approximation is possible. Okay, so the normal approximation is possible. So that's the case one. When the normal approximation positive means you are going to go to the normal distribution. Normal distribution, then you have to find the mu. Okay, and you find the sigma to get these numbers. Okay, so in the case of the binomial, you know that the mu is equal to the n times p. You already got this one. Okay, which is 26.36. So you have your mu. Then you have to find your sigma. Remember the sigma? Sigma is the square root of npq. So it's going to be the square root of n is equal to the n753 times it by 0.035 and times it by q, which is a 0.965. Okay, and you already got the first two numbers, so you multiply them to get your square root. Okay, so we get the square root. Okay, the square root of the first two was 26.36. We multiply by the 0.965, and I have 5.04. 5.04. You can check it. So that would be sigma. Any question? So you have to go through these steps. You can't do it without, you have to do it yourself. You can't do it with the calculator, this one. And now, so we check that it's possible. Now, from now on, we are in the normal distribution, because the normal distribution, you need the mu, which is 26.36, and sigma of 5.04. You bring the question. You see, what is the question? The question is probability that R, use R, because you are in a binomial case. Remember, in this case, after 15 would be 16, 17, 18, etc. But when you go to the normal distribution, it's not 15, 16. It's 15 and positive infinity, an interval. So we did have something, we call it correction for continuity, CC. So this means you change it to the P of X to be greater than. You have to find an interval that covers the 15. We talk about it, your choice is going to be 15. You go to the right, 15.5, and you go to the left, 14.5. You see, correction for continuity, to the right, to the left. It is 15, you want to be bigger than, greater than. 15 is greater than what? Is it 15 greater than 14.5, or it is greater than 15.5? You see, as you can see, the 15 is greater than 14.5. It's always the case. You consider the direction that you have. So it's going to be P of X to be greater than what? Greater than 14.5. So from now on, it's a normal distribution, and you are going to be in this format, and just keep going. With your calculator, we can get it right away. We accept it when you get to this part, of course, for this one, but I'm going to carry on, show you how we're going to do it, and then we check the calculator. But even if you use your calculator, you have to come up to this. Any question? So this is where you shouldn't miss. Most of the people, they stay with 15. It's not. It's 15, 16, 17. You have to give us an interval, okay? 15 bigger than what? 14.5. If it's going to be less than, then you pick the 15.5. Only 0.5 to the right, to the left, okay? So let's go and find the Z score. So this is it. So the X is equal to the 14.5. Then we get the Z. Okay, Z of X minus mu over sigma. So the X would be 14.5 minus mu. Mu is 26. Okay, that gives it 26.36 and divided by the sigma, which is 5.04. Okay, that's a Z number. You need it for the 2 decimal places. So let's find out. It's going to be 14.5 minus 26.36. Okay, and this is the one you divided by 5.04. Okay, 5.04. So that gives you negative 2.35, 2 decimal places, okay, for the table that we have. So it's going to be negative 2.35. Okay, so you change it to the Z, so you want to find P of Z to be greater than negative 2.35. So it's going to be area to the right. You say that's going to be the one. So it's a negative 2.35. Is area to the right. You know that you go to the Z table and you get this number. And then, of course, you subtract it. So the result is going to be 1 minus whatever we got for the 2.35. Negative 2.35. Negative 2.3 first. You see that's a negative, is that negative 2.3? 5, 1, 0, 1, 2, 3, 4, 5, 0, 0, 9, 4. Okay, 0.00994. Okay, and so the final answer is going to be, okay, that's 0.094. So we get quite a lot. It's going to be 0.999906. So that gives me 99.06%. So the chance that more than 15 or more of these people would be alive after 99 years old is almost 100%. It's very good. As you can see, it takes times. That's part one. You know, we should just give you one part on the test, but we can use your calculator to. But you have to come here to get the calculator to get this result. Okay, so I'm going to check the calculator too. Just make sure that we have it. So this is going to be. You have to go to the distribution. Remember, normal distribution. So this is going to be normal. So the lower one is 14.5. This is the lower 14.5, and the upper one is infinity because it's 14.5 up. So remember 1e99. Then the mu. What was the mu? 26.36, and the sigma, and the sigma of what was the sigma? 5.04. That's it. Paste it and get it. That's it. 99.26. Not bad. Okay, so you're gonna get the 99%. So you can use your calculator, but as I told you, you have to prove that the normal is possible. The normal distribution is possible. You need the condition to check. You need the sigma. You need the mean. Then you can get to your calculator if you want to do this one. Okay, I do the second part next time, but I just give you a hint because everything is the same. Look at this one, but we give you one of them only. These are all the 3 possibilities for you. You see, the second part, they want the number of these people to be between between 25 and 35. You want the R to be between 25 and 35. So you have to correct for continuity because you did everything else. You see what you are going to do is, this is CC, correction for continuity. This is P. This is going to be X, less than what and greater than what. You see that's 35. You want it to be less. Remember, 0.5 to the right, 0.5 to the left. 35 is less than what? Is it less than 35.5 or 34.5? You know that it's going to be less than 35.5 because of the direction. Okay, this part, 25, greater than. 25 is greater than what? 25.5 or 24.5? It's going to be 24.5. You see, that's how we're going to do it. Okay, for each one of them, you can only go 0.5 to the right, 0.5 to the left. That's a 35, you see that's a 35. You can go only to the 35.5 and the 34.5. But you want it to be less. You see, direction must be consistent. So it's less than this one. For the 24, you see 24.5, 23.5. You want it to be greater than. You see, this is it. That's a 25, sorry. So 25 is greater than this one, 24.5. So the direction would tell you what you're going to do. So the rest is going to be the same. We'll finish it next time. So you have to find the z-score, or you can use your calculator to get these numbers right away because we have all the information. So let's do this one with the calculator to see. That was normal. Remember number 2. So now the lower one is 24 at 24.5. Okay, the upper one, you have to change it. The upper one is 35.5. Everything else is the same. So your answer must be, that's it, 0.5, almost 50%. Okay, we confirm it next time. It's going to be the 0.5. Because 26, yeah, it's going to be 0.5. 0.5 or 50%. You can check it, next time to make sure it's right. Okay, so the normal distribution, and that's why I did this one. So you think about it. If you have any question, you can bring it. I can do another one for you. I put one on there that take on one. So just make sure you are able to do this problem.